Okay, so welcome to Calc 2. Let's do a quick little refresher of some of the basic derivative rules and antiderivative rules and techniques that we'll need to know that you probably learned in Calc 1. So this is a document that you guys all have posted on D2L. Some first couple pages are just some basic derivative rules and integral rules. So some of the basic ones that we started off with that you still need to know from Calc 1 would be the derivative using the power rule. And the power rule was something like the derivative of x cubed is 3x squared, etc. We also had what was called the product rule, so the derivative of a product of two functions, as well as the quotient rule, and then also the one that we're going to use probably the most often, which would be the chain rule. And so these are kind of some of the more basic rules from Calc 1. Also on this first couple of pages is some formulas. Hopefully you have them memorized. If not, you definitely want to have them re-memorized just to be successful in this class. So the trig derivatives, trig integrals, log derivatives, exponential derivatives, and then of course exponential and log antiderivatives or integrals. All right, so let's practice. Let's practice a few of them, stuff that you've seen in Calc 1. So right at the beginning, these are indefinite integrals because I don't have bounds. So I'm looking for just some basic antiderivatives. So number 1, the integral of 3x squared. So an antiderivative using the power rule there would become a 3x cubed over 3. So we add 1 to the power, divide by the new power. Same for each of those different terms, 12x to the 7 over 7, and then plus. And then the antiderivative of sine is negative cosine because the derivative of cosine is negative sine. And of course, don't forget your plus c. And then you can simplify along the way. I'm going to make sure that we practice the simplification anytime that you can simplify. So the 3's canceled in this case. I think that's just about it. Minus cosine of x. And don't forget your plus c because it was an indefinite integral. Ta-da! All right, let's just go through a few more of them. This number 2, something that if you know the antiderivative right now off the top of your head, that's great. You're supposed to be able to. If not, there is something that we're going to show that we'll probably use a lot in Calc 2, so it's worth your time to remember is that 4 is a constant multiple, so it can be factored out of the integral. And you can think of that as a 1 over x dx, so that 4 is a constant multiple. And the antiderivative of 1 over x dx is ln of the absolute value of x. Don't forget the plus c. All right, let's do another one. So number 3, same idea. I'm going to go through and show the work for this one. And then I'm going to let you know that you can skip the work if you feel like this is one that you should already know the answer to. So what I mean by that is I'm going to do a u sub. So I'm going to let my u be that entire denominator here, which was x minus 3. Then du, well, the derivative of x was just 1. So that's maybe a little bit easier of 1. And then the antiderivative would be the other direction. But here, that's just a basic derivative rule. And then when I do the integration, this can now turn into 2 over u. And I'm just going to point out in this particular case, that dx really did just turn directly into a du. So an easier u sub, a very easy one. And then this looks just like number 2, where that 2 is a constant multiple. And the antiderivative of 1 over u is ln of the absolute value. And then when you do a u sub for an indefinite integral, don't forget to replace that u. Ta-da! All right, so now this is something that you should have learned in Calc 1 and for all of Calc 2 and all of the work that you guys will have to show on either an exam or a test. I just want you to know you are welcome to skip the u sub when it's that basic. Okay, if it's a simple one that you can kind of just do that u sub either in your head or maybe you just already know that antiderivative, you are more than welcome to just skip that u sub. Okay, let's do another one. So number 4, same idea, just slightly harder because I have a little bit more numbers, but it's really the same idea. So I'm still going to do a u sub. Let u be 5x plus 1. Then the derivative of 5x is 5. Don't forget the differential. If you've got a differential on one side, then you have to have a differential on the other side of that equal sign. And now in this example, my integrand just has dx. So I should try to isolate that dx. So I can rewrite that to be du divided by 5 is dx. And then when I go in and replace that into my integrand, I'll get the integral of 3 over u. And instead of a dx, I have a du divided by 5. Instead of a dx, it got replaced with the du divided by 5. All right, and then in this case, I'm going to show a little bit more work as well, just to simplify it. That 3 and divided by 5 is a constant multiple, so you can take that outside the integral, and then it becomes something just like the last couple of problems where you have the ln of the absolute value. Don't forget your plus c. Make sure you write that nice and organized, and then I can replace my u with the 5x plus 1 plus c. Ta-da! Now here is an example of one that you can skip the u sub if you want. This one's maybe a little bit harder to do the u sub in your head, so you certainly don't have to, but I just want to point out that you are going to be allowed to if you want. So I'm going to give myself a little bit of space here and rework a different problem just like that. So if we look at my original question and the final answer, you're going to see because it was linear on the bottom, I still had the ln, right? This was just an x. It wasn't an x squared, an x cubed, or a square root of x, or a sine of x. It was just linear on the denominator, which means I ended up with that ln. And then 3 was a constant multiple, so 3 stayed. And then what I did is I divided by the constant multiple of the linear denominator. So let me give you a couple of quick examples where you can. I'm going to leave that up on the screen actually, so you can skip all the u sub. If I have the integral of, let's say, -2 over 3x plus 5. All right, -2 was a constant multiple. It can stay. It's linear on the bottom, so I'm going to have a ln. Don't forget your plus c. And I have to just divide by the constant multiple of that linear term. That is skipping the u sub. Let me show you again. It's worthwhile to see a couple of extra practice so you can see that it's going to work only in that special case when it's linear on the bottom. So let's say I have pi divided by 5 minus 2x dx. Okay, here's another one where it's linear on the bottom. So I'm going to have an ln of that entire denominator. And then pi was a constant multiple, it stays. I just have to divide by the constant multiple of that linear term. So in this case, that was a -2. The constant multiple is the thing that's multiplied by the x, or the slope of the linear piece. All right, so you, like I said, you're allowed to skip that u sub if you want. All right, let's practice a little bit more. Let's do another one. This one is an example number 5 here that is not linear on the bottom, so I can't do that trick. I really just have to do the regular antiderivative. So I'm going to rewrite that as 4 times x to the power of -1/2 when you have a square root on the bottom. That's going to be a exponent of 1/2 for the square root, negative because it was on the bottom. 4 is a constant multiple, it can stay. And then I'm going to add 1 to the power, and -1/2 plus 1 is +1/2, and divide by the new power. And then the way you divide by fractions is you multiply by the reciprocal. So I end up with 8x to the 1/2 plus c, or you could write that as 8 square root of x plus c. Ta-da! All right, let's do another one. We're on a roll. Number 6. This is an example of one that you have to simplify first, because there is no quotient rule for antiderivatives. There is no quotient rule for antiderivatives. So I really do need to break up that fraction first. So then this is going to become the integral of x to the power of 5 over x squared minus 6x over x squared dx. And then I'll continue that simplification. The integral of x cubed minus, that becomes 6 over x. You subtract those exponents, and then one of those x's canceled. There we go. And then you can do the antiderivative. So add 1 to the power, divide by the new power. And then remember, now when it's linear on the bottom, that's where you get the ln. This one didn't have a constant multiple. Its multiple was just 1. So it's technically divided by 1 that I don't need to write. Plus c, ta-da. Ta-da. All right, let's do another one. Number 7, same idea. Here's one that's kind of tricky. Oh, and there's a small typo. Let me fix that. There should be a dx there. Just a minor typo there. What I need to do here is I need to notice that this looks almost like it's linear on the bottom, but it's not. It's the square root that makes it not linear on the bottom, so I can't do that shortcut. I really just have to do the good old-fashioned simplified out. So what I'm going to do now, it's not going to have an ln because it's not linear on the bottom. So that's what I mean by that. There's not going to have an ln. But I am going to rewrite this as 3 times 2x plus 5 to the power of negative 1/2 dx. Now, I know it's not linear on the bottom, so I know I'm not going to have an ln, but it is still linear on the inside. And so that when it's linear on the inside, I could skip the u sub. Now, you don't have to if you don't want to. You could let your u be 2x plus 5, and then your du would be 2 dx. So your dx would be du divided by 2, etc., etc. But that divided by 2 is dividing by that constant multiple, so I can skip the u sub because the inside was linear. It's not going to be an ln, but I can still skip the u sub. So what I mean by that is that 3 is a constant multiple. It can stay. I can just do the antiderivative as it is, which is add 1 to the power, divide by the new power, but then also divide by the constant multiple. And I'm going to highlight that because I think it's worth our time to see it. The constant multiple of the linear part. There we go. Okay, and then of course the plus c, and then I'll simplify. This one happens to be 3 times 2x plus 5 to the power of 1/2 plus c. Ta-da! All right. Or you can show the work for the u sub every time if you prefer. It's up to you. All right, let's do another one. Let's do example 8. Now this is a definite integral. So here is an example of one that I have bounds, so I'm not going to have a plus c. So this is going to become add 1 to the power, divide by the new power, add 1 to the power, divide by the new power. The antiderivative of 2 is just 2x. And then I evaluate that from 1 to 4. This was using the fundamental theorem of calculus part 2. Hopefully you remember that from Calc 1. It's pretty fundamental to calculus. And then I'll plug in my bounds. So I would have gotten 4 cubed over 3 plus 4 squared over 2 minus 2 times 4. And then minus, I plug in the other bound. So 1 cubed over 3 plus 1 squared over 2 minus 2 times 1. And then you can plug that into your calculator. I highly recommend that you do. And if you've got your calculator with you, what I also recommend that you do is I'm going to show you guys that. I'll just show it to you really quick. Let's see if I can find the app. Sorry about that. I want to show you a trick on the calculator. So for example, I had a 4 to the power of 3 divided by 3. And then it was plus a 4 to the power of 2 divided by 2. And I don't remember the rest of it, but there was some other stuff. But if I wanted to combine those two together, you could click enter, but that'll give you a decimal. If you click the math button first over there on the left, and then yours calculator hopefully looks a little bit different than this, and then just press enter twice or select the FRAC for fraction, then it will give you a simplified fraction. Okay, now I wouldn't go through, I have my regular calculator here in front of me, and I ended up with typing that whole thing into my regular calculator. I ended up with 45 divided by 2. Ta-da! Okay, all right, let's do some more. Excellent. All right, so same idea. Here's one that is another indefinite integral. So I'm going to have a plus c, no bounds. So the 2 over x, the 2 is a constant multiple. The linear on the bottom is what gave me the ln minus. Oops, that was a minus, sorry. And then the antiderivative of e to the something, I'm going to highlight this as well. That something or that inside is linear. E to the x is not linear, but just the inside part is linear. So I can skip the u sub, meaning it can just become e to the power of 3x because the antiderivative of e to the x is e to the x. And then I divide by that constant multiple. That was me skipping the u sub. Plus same thing. Now secant is not linear, it's not, but the inside is linear. So I get to skip the u sub when the inside is linear. If this were an x squared right here, this process would not work. It only works when the inside is linear there. The antiderivative of secant squared is tangent because the derivative of tangent is secant squared. And then I divide by that constant multiple and plus c because it was an indefinite integral. Ta-da. One more practice if you want just one more quick practice on something similar to that. What if I had the antiderivative of 4e to the let's say 3x minus 1 dx. So 4 is a constant multiple, it stays. This is an e to the power of linear. So because that inside is linear, I don't have to show the work for the u sub, but you could do a u sub is what it's actually doing. And the antiderivative of e to the x is e to the x, and then divide by that constant multiple. Okay, let's keep going. We're on a roll. Let's do number 10. More antiderivatives, extra practice. The antiderivative of secant times tangent is secant because the derivative of secant is secant times tangent. The antiderivative of sine is negative cosine. The inside was linear, so I just have to divide by that constant multiple. And I would rewrite that because plus a negative is just minus to simplify my work. The antiderivative of sine is negative cosine. The derivative of sine is positive cosine, opposites there. All right, let's do number 11. Here's another one where quotient rule for antiderivatives doesn't exist, so I have to break up that fraction. This will become the integral of x cubed over x to the 3/2 plus the square root of x over x to the power of 3/2 dx, which will turn into, I can subtract those exponents, so maybe you have a little scratch piece of paper, or maybe you use your calculator. 3 minus 3/2. You can use your calculator. Make sure you use that math fraction button though, to make sure you realize what it actually is going to simplify to, because I'm going to want you to leave that as a fraction. And it did turn out to be 3/2. So this becomes x to the power of 3/2 plus, and then, ooh, sorry, there we go. For that second one, that was an exponent of 1/2 and then an exponent of 3/2. So when you're dividing, you subtract those exponents. That became a negative 2 over 2, which is just a negative 1. So this is now an x to the negative 1 dx. Then I do the antiderivative, and I'm going to add 1 to the power. So now I'm doing this antiderivative. All that fraction stuff over there is done with. That's sort of my scratch work that's done off to the side. When I add 1 to the power now, I'm going to get 3/2 plus 1 divide by that constant multiple. Now try to add 1 to the power over there. We can't divide by 0. So you have to remember that x to the negative 1 is 1 over x. So then that's going to help you remember that that one turned into an ln plus c. And then I simplify because I should flip the fraction when you're dividing by fraction. So 2/5 x to the power of 5/2 plus ln of x plus c. Ta-da! All right, let's do another one. We're on a roll. Number 12. Here's another one. Excuse me, there is no product rule for antiderivative, so I can't just take the antiderivative right now. Here's one where my inside that I have highlighted right here is x to the 6 plus 12. That's not linear. So I cannot skip the steps like I've been doing for those first few. I actually just have no choice. I'm going to do a good old-fashioned u sub. So I'm going to let my u be that x to the 6th plus 12, and then du, the derivative of x to the 6th, is 6x to the 5th dx. Don't forget the differential on both sides. And then this one has a 12x to the 5th dx inside my integrand. Here I have a 6x to the 5th dx. So I want to manipulate what I have until I get what I want. Definitely more than one way to do this. There really just is. One way that I find useful is to just get rid of that number 6, because constants have never been the hard part to integrate. Numbers are never a concern. It's the variables that are tricky that we're trying to simplify, because then I can realize that this x to the 5th and dx could now get turned into the du over 6. So then this integral becomes the integral of 12 is just 12. Don't let the numbers scare you. So the numbers just are what they are. And then I have a u to the power of 12 du divided by 6. Let me point it out to you again. So if you're watching, there's kind of a lot on the screen, so maybe pause what you're writing down and just watch for a second. It's this entire x to the 5th and dx that got turned into this entire du over 6. And that's why the leftover was the 12, and then that parentheses to the 12. Okay, all right, so now we can continue on with that integration. 12 divided by 6 is just 2. And then I'll do the antiderivative, so 2u to the 13 over 13 plus c, because this was an indefinite integral. So I got 2 over 13 times x to the 6th plus 12 to the power of 13 plus c. Ta-da! Right. Just a couple of more. Let's do number 13. Same kind of idea. There's a u sub situation here. I'm going to rewrite the question. You don't have to, but I want to rewrite it so that you guys are all aware of the other way this can be written. Cosine cubed. I don't know. It's always kind of weird to see that cosine cubed like that. What it actually means is cosine of x cubed. That's really what it means. I think that's more visual. You don't have to write it that way. You don't. So long as you know those two are equal, you're going to be in good shape. And the reason that second one, in my opinion, is a little bit better is because it's very visual. You can see what's on the inside. So it makes practicing with u sub a little bit easier, really. All right, so let's do the u sub. I'm going to let my u be cosine of x. Now I need to do the derivative. The derivative of cosine is negative sine. We're doing a derivative there, not an antiderivative. Tricky, I know. And so then my integrand does not have the negative. So I should bring that negative to the other side and I'll get negative du is sine of x dx. And now I have, let me maybe kind of highlight that better. Now I have a sine of x dx that will get replaced with a negative du. So then this is going to become the integral of 3u cubed times negative du. And I am going to highlight it. It was this sine and dx that got replaced with the negative du. And then I'm going to simplify that because that's always tricky. That negative and the 3 are the constant multiples, so they can come outside the integral. And then it's easier to do the antiderivative and then replace it because I had an indefinite integral. So negative 3/4 cosine of x to the power 4 plus c. Ta-da! All right, let's do another one. Just a couple more practice with u sub. So same kind of idea here. I don't have my inside being linear. It's hard to see the inside, I think. At least I think a lot of us struggle with it. When you have e to the something, that something is your inside. That's kind of where you thought of chain rule. Think of it when you were thinking of chain rule, when you were first learning chain rule. All right, so either way, let's do the u sub here. So I'm going to let my u be the square root of x. It's this guy right here, that inside. Okay, and then the derivative of the square root is 1/2 times the square root. Hopefully you remember that from Calc 1. You definitely need to know that one as well. And then I'm going to simplify this. I'm going to bring this 2 to the other side of the equal sign because I don't have a 2 in my integrand. And in this case, because the 2 is on the bottom, to bring it to the other side, it's multiplied both sides by 2, and then I ended up with that 1 over the square root of x dx. So I have a dx over the square root of x now. And so that whole thing can be replaced with the 2 du. So this turns into the integral of e to the u times 2 du. I'm going to highlight it. I know that's a lot going on. Let me highlight it one more time. So if you didn't catch that, watch this really quick. My square root of x in the exponent turned into a u, because that's what my u is equal to. But then my square root of x on the bottom and the dx turned into a 2 du. All right, then we can integrate from there. And then it becomes a little bit easier to integrate where that 2 is a constant multiple, it stays. And the antiderivative of e to the u is e to the u. And then I just replaced my u, ta-da. All right, let's do another one. One more, slightly trickier, but very similar to stuff that we've been practicing. We're just getting a lot of practice with Calc 1. These are the types of antiderivatives you want to make sure you know how to do. Here's another example of a quotient. There's no quotient rule for antiderivatives, but because I have 2 things on top, I can break up the fraction, or I have multiple terms on top and only one thing on bottom. So I'm going to break up that fraction, and then this is going to turn into the integral of cosine of x over secant of x plus sine cubed of x over secant of x dx. And we have to remember our trig. Secant is 1 over cosine. So this becomes cosine over 1 over cosine, which becomes cosine times cosine, which is a cosine squared plus, okay, good. And then this is a secant is 1 over cosine. So dividing by secant is the same thing as multiplying by cosine. All right, and then this is where it becomes quite tricky. I'm going to break this up into two separate integrals. This is now the integral of cosine squared of x dx plus the integral of sine cubed of x times cosine of x dx. And the reason I broke it up is this second integral looks just like the one that we did earlier, which is just a basic u sub. I can let my u be sine. That'll be an easy one. This cosine squared is a little trickier, and we're going to do a lot of this semester, so this is worthwhile for us to remember. There are plenty of trig identities to remember. One of them in particular is cosine squared of theta is 1 plus cosine of 2 theta over 2. If that were a sine squared of theta, sine squared is 1 minus cosine of 2 theta divided by 2. All right, we got this. So this is going to become the integral of 1 plus cosine of 2 theta divided by 2, although I guess I had an x, not a theta, so I'll keep my variables correct. And then now I'll break up that fraction, which is a 1/2 plus 1/2 cosine of 2x dx, which becomes then a 1/2 x plus 1/2 the antiderivative of cosine is sine, but the inside was linear, so I can divide by that constant multiple. So 1/2 x plus 1/4 sine of 2x plus c. There is a plus c, but I have to remember we got to go back and do the other half. That was only the first half. So I'm going to scroll back up. We can do it. I'm going to scroll back up. Remember that second half that we got to do? This one required a u sub. We can do it. I'm going to let my u be sine of x. The derivative of sine is cosine. Luckily, that matches perfectly. That doesn't always happen, but when it does, it's kind of nice. So then this turns into a, copy this down. This is going to now be a plus the integral of u cubed du, because the du turned into, or sorry, the cosine of x dx turned into the du. There we go. Okay, we got a lot highlighted there. So I'm going to undo some of that highlighted. It got a little bit crowded. Let's keep going. So then plus u to the 4th over 4 plus c. And then, of course, my u in that u sub. If I were to go back and look, my u was sine. So that becomes sine of x, sorry, there we go, to the power of 4 over 4 plus c, which you can write that as 1/4 sine to the 4th of x plus c as the final answer, combining both of them. Ta-da! All right, obviously that's not every single thing you need to know from Calc 1, but hopefully that helps refresh your memory of some integration techniques. We're going to do tons of integration in this class, so I hope you find that helpful. Thank you.